Hello everyone. In this tutorial, we are going to see how to generate Docstring using a pre-trained CodeLlama-13b model. For this tutorial, we are going to use a platform called Predibase that can be used to fine-tune or deploy any large language model. Before we begin our tutorial, let us try to understand the task. We all know that Docstring is an essential part of good software engineering practices. By writing relevant docstring, we can ensure that a code written by a developer is well understood by others. In this particular tutorial, we'll be generating docstring given Python functions. So we have Python function and we want to generate the relevant docstring given that Python function. So first step is to get the relevant dataset, for which we can use codex glue data. We can follow the steps mentioned in the GitHub. So in this particular repository, we have docstring for different programming languages like Java, Ruby, and Python. We're only going to use Python docstring generation as part of this tutorial. So once we follow the steps, we can get JSON files under each programming language folder. So we can read these JSON files using pandas. Once we read the files, we can see this set of columns. So this original string is the column that contains the code along with the code docstring. And the docstring column contains only the docstring. So from these two columns, we can derive the raw code without any docstring. So the input to our large language model will be the raw code without any docstring, and the output will be code with docstring. Before we begin our fine-tuning process, we need to set up Predibase, for which we need to install the Predibase APK using pip install, and then we need to log into our Predibase account, for which we can use pbase login command. After we perform pbase login, we'll be prompted with the API token. Once you put your API token, you can connect to the Predibase client. Predibase has integration with various platforms like Hugging Face, which can be used to get a pre-trained large language model. In this tutorial, we'll be using CodeLlama-13b instruct model from Hugging Face. For computational purposes, we're not going to use the entire training data to fine-tune the model. Rather, we'll use only a small subset of the training data. First, we need to create a Predibase dataset. From this data, either you can use create dataset from df and you can upload your data to Predibase, or if you already have a Predibase dataset, you can use get dataset method and get the dataset by referring to the dataset ID. To fine-tune a large language model, we need to define the prompt because this is an instruction tuning. For this docstring generation, we can use this following prompt where the input to the model will be the raw code. Once we have the prompt, we can use the .fine-tune method to fine-tune the large language model. Once we initiate the fine-tuning process, we'll be given an URL to track the experiment. So in this URL, you will find all the relevant statistics like training loss, testing loss, along with the evaluation metrics. So for instance, this is a text generation process. So you can find BLEU score, root score, and many other metrics. Once the fine-tuning is complete, you can use .get method to get the fine-tuned model, or you can refer to the model ID and use the get model method to get the fine-tuned model. The final step is the model testing. So we want to test the fine-tuned model on a test dataset. For that, you first need to use the base deployment or the original pre-trained model. Predibase already has deployed several pre-trained large language models. CodeLlama-13b is one of them. So we can directly refer to the Predibase deployed model, and we can use the fine-tuned model as an adapter on top of the base deployed model. Once we have the adapter, we can run inference on any test data using the prompt method. So you need to pass the input in a dictionary format along with the additional parameters like maximum number of tokens. And then you can get the response. So now we want to evaluate the fine-tuned model on the test dataset, for which we'll be using Rouge metric. Rouge metric is a very popular metric, particularly made for evaluating text generation models. So we'll be using Rouge L F measure, for which we'll be using torch metric library. And then we can compute this Rouge L F measure on our entire test data. Again, for computational reasons, we're not going to use the entire test data, rather only a subsample of it. And then we can compute the average root score on the entire test data. So as we can see that the average root score for the original pre-trained large language model is 0.23, whereas the average root score for the fine-tuned CodeLlama-13b model is 0.78. So you can understand that in just 3 or 4 epochs, the fine-tuned model was able to perform significantly better than the original pre-trained CodeLlama model. As an additional evaluation metric, we're going to use a semantic similarity measure, for which we'll be using a pre-trained sentence transformer model. Once we have a sentence transformer model, we can compute a vector embedding for the ground truth as well as the generated docstring, and we can compute cosine similarity. And again, we can compute the average cosine similarity on the entire test data. So as we can see that the average similarity for the original pre-trained CodeLlama model is 0.74, whereas the average similarity for the fine-tuned CodeLlama-13b model is 0.91. So even under this measure, the fine-tuned model performs significantly better than the original pre-trained model. With this, we end our tutorial. So in this tutorial, we saw how to use Predibase to fine-tune a large language model for docstring generation. Although we have used Python codes for the docstring generation, this tutorial can be extended to any other programming language. With that, we end our presentation. Thank you.